On page number 4, you're going to see 2 more calculations. Again, the same thing, but with different masses. 8.00 divided by 35.0. Then 0.80 divided by 35.0 milliliters. So each one of these is going to show us a density calculation where we are looking at the number of significant figures to dictate, well, the number of significant figures that our answer ultimately has. So on page number 5, this gives an explanation as to how to use a piece of glassware like a graduated cylinder. And essentially, what this shows is you need to be familiar with this piece of glassware, and you need to be familiar with the demarcations on each piece of glassware. Now on this piece of glassware, what you'll see is, you'll see something like 10. So this line right here corresponds to 10 milliliters. This line right here corresponds to 20 milliliters. And there are markings to indicate 11, 12, 13, 14, 15, 16, 17, 18, and 19 milliliters. So this has markings corresponding to 1 milliliter difference. Now, whenever you're looking at this, obviously the level of your solution might not be exactly at one of those. It might be above, it might be below. Now, what that gives you a way to, or those demarcations show you approximately what's a reasonable estimation. So if my solution level is between 11 and 12 milliliters, could I say that I have 11.65 milliliters of a solution in there? Potentially. Could I, if I compared that to 11.655, that's getting pretty hairy. Now, I have a marking. I have basically 2 kind of landmarks. I have 11 milliliters and 12 milliliters. Really, the safest calculation or the safest estimation that you can make would land between 11 and 12. And so you couldn't really say something to the hundredths position, but you could say it to the tenths position. So 11.4 or 11.5 or 11.6, those are reasonable and acceptable answers. 11.55, well, how do you know that it's 11.55 rather than 11.56? You really don't. You can't visualize that easily. Are there pieces of glassware that are that precise to the thousandths position or the hundredths position? Absolutely. You need to be familiar with the markings on your different pieces of glassware. All right, pages number 6 and number 7 introduce you to the different pieces of glassware, and you're asked to draw each of these pieces of glassware. And I'm gonna ask you to do that as well. I'm gonna compare and contrast the first 2 pieces of glassware. This right here is a large beaker. This has a maximum measurable volume of 400 milliliters. This right here, they're at the same plane. This is a 100 milliliter plastic beaker. This is your small beaker. This has a maximum measurable volume of approximately 100 milliliters. Now these 2 pieces of glassware, you could find a 200, you could find a 250 milliliter plastic beaker, but here is a 400 mil, and here is a 100 mil. They obviously hold different volumes, not only because of the markings, but you can look at them and see that they are different. The next piece of glassware is a kind of unique one. It's known as a volumetric flask. It has a flat bottom to it, and then it has this long neck, okay? Now this particular volumetric flask has a marking on it that says that it holds 50 milliliters. Now if you look at if you inspect this piece of glassware, I don't really see too much. However, I see this red line, and then I see this line right in the middle, this etched line. Now what that corresponds to is exactly 50 milliliters. So what that tells you is this piece of glassware basically does one thing, but it does it well. If your solution goes above that 50 milliliter marking, what do you know about it? You know that's more than 50. If it's below that, you know it's less than 50. You can't really, with much confidence, make an estimation as to what that volume is. Like I said, this piece of glassware is good for one thing, and it's reliable for that one thing. This will measure 50 milliliters of a solution. It won't measure 55. It won't measure 45. It will measure 50 milliliters. The next piece of glassware is an Erlenmeyer flask. It's a little bit similar to a volumetric flask. It also has a flat bottom and then it has this kind of curvature to it, but it's kind of triangularly shaped, and it's a little bit shorter. This piece of glassware can measure 125 milliliters of a solution. This is a piece of glassware that's very effective for, well, collecting volumes ranging from 50, 75, 100, and 125 milliliters of a solution. The last piece of glassware is this guy right here. This is a graduated cylinder. This graduated cylinder has a maximum measurable volume of 100 milliliters. If you go above that marking, what have you collected? Well, you've collected more than 100, but you can't really measure what that volume is.